Good morning. This morning, our video lesson is on multiplying a decimal times a whole number. So we're going to look at a couple of different examples. For the first one, if you're presented with a problem like this, remember, you could do this mental math, but another strategy which might be easier for your brain is to stack them. Which number gets stacked on top? It's going to be the one that has the most digits because our brains just feel comfortable with that. So I'm going to stack it up like this. And now I'm going to ignore that decimal point for now. You can think of it like a little rabbit turd that you don't want to step on, but you want to be aware of. And I'm just going to multiply the way I know how. So 3 times 2 is 6. And 3 times 5 is 15. I carry my 1 to the next place value and I write the 5. 3 times 0 is 0, but then I add the 1. Now, we have to decide what to do with that little decimal point. Where does it go in our product, which means in our answer? Well, if I start at the back of the number where the decimal point is, how many place values do I shift until I get to the decimal point? I shift 1, 2 places. How many places do I shift here? The decimal, if we don't see it, is always at the back of the number. Well, it doesn't shift at all. So when I add up how many places the decimal point shifts, it's going to shift 2 places. So I start at the back of my number and I shift it forward 2 places and I stick that little rabbit turd right there. It's a little decimal point right there. So my final answer is 1 and 56 hundredths. Let's take a look at one that has a little bit higher numbers with a little bit more digits. Okay. So here's that problem. So we have 65 thousandths. It's not a very high amount, but it does have digits, 3 digits behind the decimal point. Don't let that scare you. We're going to stack that number on top because, again, altogether, it has 4 digits and 18 only has 2 digits. So now I'm going to ignore the rabbit turd, ignore the decimal point, ignore those zeros in the front, and just think of it as 65 times 18 because I know how to do that. So 5 times 8 is 40. 8 times 6 is 48, plus the 4, 48, 49, 50, 51, 52. 8 times 0 is 0, plus I add the 5, and that is 5. Now here's a strategy that I like to use, and I'm even a grown-up, but this helps me make sure that I don't repeat work that is going to make me have a mistake. I'm done with the 8. I'm going to slash it out. I'm done with the 4 I carried. I'm done with the 5 I carried. Now I'm moving on to the next place value, the tens place where the 1 is. So now I'm going to take 1, and what do I need here in the ones place? I'm done with the 8 in the ones place. I need a placeholder, and because I'm a rock star, I'm going to make that placeholder into a smiley face to remind me that I'm a rock star and to remind me, good job, Mrs. Delat, you remembered the placeholder. So now we do 1 times 5, 1 times 6, which is 6, and 1 times 0, 1 times 0, those are both 0. I could put zeros out there in the front, but why? It might just confuse me. Now I'm going to add up my amounts in the bottom. 0 plus 0 is 0, 2 plus 5 is 7, and 5 plus 6 is 11. Write the 1 and carry the 1. That one I carried plus 0 is 1. Now we have to decide what to do with that rabbit turd, what to do with that decimal point. Notice that I didn't put the decimal point anywhere in those numbers. I saved it for the very end because I don't really want to touch a rabbit turd if I don't have to. So we start at the back. How many places did it shift forward? 1, 2, 3. It shifted 3 places to the front. And 18, where's the decimal point? I don't see it. We always know it's in the back. How many places did it shift forward? 0, because it stayed put. So there's a 0. If we add those numbers of shifts together, we end up with 3. That means that in our product, we're going to shift that decimal point 3 places to the front. I start at the back and I shift forward 3 numbers, even with the 0, because that's my placeholder. 1, 2, 3. And I plop my decimal point in right there. So this means that my final answer is 1 and 170 thousandths. But you might notice, do we need to keep that 0? It's at the very end of the number and it's behind the decimal point. We don't need to keep that. So another way to write that would be 1 and 17 hundredths, tenths, hundredths. I had to think about that for a moment. So these are both equivalent numbers. They mean the same amount, but we do not need to keep that 0. If you have questions, please email me because I'm here for you. Okay? Have a great day.